Welcome back to my channel, and today we'll be discussing about vernier calipers. And a good morning to all. And so this is the image of vernier calipers, how it looks. And vernier calipers means apparatus. It's called an apparatus, which is an instrument which is used mostly in physics laboratories to measure lengths of smaller objects accurately, which could not be possible with the meter scale. Vernier calipers means nothing but an instrument which is mostly used in physics labs to measure the length of small objects. And this measuring could not be possible with meter scale. That is what they have told in this definition. And the word calipers means any instrument with two jaws which is used to determine the diameter of the given objects. So when you just observe here, word calipers means an instrument with two jaws. If you just learn this, the definition of this would be so easy, just to determine the diameter, right? And next, it was invented in 1631 by a French mathematician, Pierre Vernier. Pierre Vernier was the inventor of the vernier calipers, and so the name came as vernier calipers. So let's move to the next slide. Parts of vernier calipers we are going to discuss right now. And so first part of vernier calipers is external jaws. When you just observe in here, there are two jaws, right? These are used to measure the external diameter of the given objects. Right? Next, see, and the definition for this is the jaws which are facing the downside, means which are facing the downside, right? And they are used to measure the external diameter of the objects or width of the given objects. See, when you just, for example, take a pen. If you just take the pen and keep it in here, you'll just, and you had to just adjust these two jaws. If you just adjust these two jaws, you can know the exact diameter of the given object. Called external jaws. And so the next is internal jaws. Internal jaws. We have completed our external jaws, right? See, these were, right? See, these were external jaws, and when you have just came up, you can see, right, two small jaws which are called internal jaws. Internal jaws which are facing the upper side and used to measure the internal diameter of the given object, and they are called internal jaws. So next, vernier scale. This is a very important part of the vernier calipers, which is graduated with a special relation to the main scale, which is called vernier scale. Vernier calipers, there is a part called vernier scale, and it is very important part, and it has a special relationship with the main scale, and it has a job similar to that of main scale. Means the vernier scale and main scale have a similar job to measure the diameter. And so next, moving button. Not just only moving button, I have even mentioned locking screw. There will be a button down of the vernier scale, which is also very important because it is the button used to measure the external and internal jaws to measure the diameter, and there also will be a locking screw which is used to lock the measurement after releasing by the moving button. Just see, if you just come back to the slides, can see right in here, down of the vernier scale, see, down of the vernier scale, Down of the vernier scale could see a button which is used to increase or decrease the between measurement, and this is called locking screw. After just releasing by this button, by mistakenly it can be loosed, right? So in that case, to not be loosed like that, we'll use this locking screw. Okay, hope you understand now. And we have completed moving button and locking screw. Next, now we have completed all the parts of vernier calipers. Next, now the principle of vernier calipers. And in this, there are two systems called MSD and VSD. They are nothing but main scale divisions and vernier scale divisions. And here, when you just see, the both zeros are intersecting. Both zeros were intersecting in here. And just when you just see in here, the 9th division of main scale and the 10th division of vernier scale are intersecting. So now we can just clarify that 10 VSD is equals to 9 MSD. Right? And next, if we just transfer the 10 to the right side, 10 to the right side, means just transferring this to the right side. So it will become 1 VSD is equals to 9 by 10 MSD. So now VSD means nothing but 1 VSD, right? And VSD means is equals to 1 VSD, and whereas 9 by 10, if we just simplify that, we'll get 0.9. Cause when you just see, to convert that into decimal form, how many zeros are there? 1 0. So after the decimal point, there have to be one number. So we just transferred it as 0.9 MSD. So 1 VSD is equals to 0.9 MSD. So coming to next slide. It's the least count of vernier calipers. 1 VSD means 0.9 MSD we have learned. As the length of each main scale division is equals to 1 mm, then 1 VSD is equals to 0.9 mm. Mm means millimeter, and therefore each vernier scale division is shorter than main scale division by 0.1 mm. So they are saying that vernier scale divisions are shorter than main scale divisions. By what distance? Just by 0.1 millimeters distance. And next, we have completed explanation of vernier scale totally. And so I'm just saying the thank you with some cute bouquets. So I hope you understand, and make sure to subscribe to my channel. I kept a lot of effort and my hands were paining after typing a lot of words. And so I hope you understand. And just bye bye. Make sure to subscribe and share.